Hi everyone, today we start talking about our second lesson with matrices, and this is all about square matrices. The reason we focus on square matrices is because they have a lot of characteristics that we can do further sort of problem solving with, or applications to different types of problems. So a square matrix is exactly what it sounds like. It has exactly the same number of rows and columns. So this would be a 2 by 2 square matrix. This would be a 3 by 3. We could have a 4 by 4, 5 by 5, and so on and so forth. One particular square matrix that's important is the identity matrix. And this is a square matrix with zeros in all of the elements except for the main diagonal, which has ones. So this example that's shown in your notes is a 3 by 3 identity matrix. A 2 by 2 identity matrix would just be this section right here. A 4 by 4 identity matrix would have another row of zeros and then a 1 at the end with another column of zeros above it. And so on and so forth. It would get bigger and bigger. The reason we talk about the identity matrix is because it's important in terms of inverses. And we talked about how we don't divide with matrices, we multiply by the inverse of a matrix if we need to get rid of it. So the identity matrix is basically like the number 1. So if we multiply a matrix by the identity matrix, we get the exact same matrix out, just like if we multiply any number by 1, it stays the same. And if we multiply a matrix by its inverse, the result is the identity matrix. So it's like it undoes itself. Okay. So like we said, the inverse of a matrix is what we would multiply an original matrix by to get the identity matrix. So it's like multiplying a number by its reciprocal, essentially. So how do we calculate the inverse? Well, we need what's called the determinant. The determinant of a 2 by 2 matrix is calculated using this formula AD minus BC. If we consider a 2 by 2 matrix having elements in this configuration, A, B, C, D. So we would multiply down the diagonals essentially, and then subtract by the other diagonal. So a determinant is a special number that we use to find the matrix, to find the inverse. And we're going to find them for 2 by 2 and 3 by 3 matrices. So the symbol for finding a determinant of a matrix looks like an absolute value symbol, basically. So if I wanted you to find a determinant of matrix A, I would put the letter A inside these bars. And that means to find the determinant of it, or to multiply down the diagonals and subtract them. For a 3 by 3 matrix, it's a little bit harder to find the determinant. We basically create 3 2 by 2 matrices using this formula. So it looks complicated, but really if we kind of isolate just what we're looking at, so we're going to multiply the first row, first column by the 2 by 2 matrix that's formed by eliminating anything else that's in the same row and the same column as A. And then we subtract the second 2 by 2 matrix. So in row 1, column 2, we eliminate these other two numbers and this column, and we multiply by the 2 by 2 matrix that's formed by eliminating the numbers in the same row and same column as B. And then we do the same thing with C. We eliminate all the numbers in row 1 and column 3, and then we multiply to find the determinant of that resulting 2 by 2 matrix. So we multiply, we subtract, and then we add. Okay. So we're going to do some practice with this so we can see. Oops. Okay. So if we take a look at this 3 by 3 matrix, we multiplied the 6 times -2 times 7 minus 5 times 8. So the negative 2 times 7 gives us negative 14. 5 times 8 gives us 40. Negative 14 minus 40 is negative 54. And then we multiply it by that 6 that's in front. Then we subtract 1, and we're going to now ignore the 6, the 1, the negative 2, and the 8. We multiply 4 times 7 and subtract 5 times 2. So that gives us 28 minus 10, or 18. So that's how we got this number. And then we add 1, and we eliminate these numbers now and focus on this 2 by 2 matrix. We multiply 4 times 8 minus negative 2 times 2. So it's 32 plus 4, or 36. And then the last step would be to combine all these numbers. 6 times negative 54 minus 1 times 18 plus 1 times 36 gives us negative 306. That would be the determinant for that 3 by 3 matrix. One thing that we glossed over that you will have to do is you will not have to find the inverses of 3 by 3 matrices. I will show you how to do that in the calculator, but you will have to find the inverse of a 2 by 2 matrix. So remember, the determinant of a 2 by 2 matrix is really easy. It's just AD minus BC. And I told you that we use that to calculate the inverse. So to find the inverse of a matrix, we multiply 1 over the determinant by this, we call it like a comatrix. We swap the positions of our A and our D, and we change the signs of our B and C. So that will give us our inverse matrix of a 2 by 2. So take a look at some of the practice. Let me know what questions you run into. And my only, I guess, tip here would be to be very, very careful. It's so easy to make a mistake because you're dealing with so many different numbers and signs. So just be very, very careful. Take your time and double check your work. But none of the math that you're doing here is difficult. It's all basic multiplication, addition, and subtraction. Okay, so let me know if you feel like you want extra help, and I will see you guys in the next video.